Together, we're going to look at a geometrical definition of a parabola. A parabola is a conic section, and we're going to model this geometrical figure with an equation based on the definition. Now, we can say that a parabola is the locus of points, that is to say, the set of points x comma y in a plane that are equidistant from a fixed line, namely a directrix, and a fixed point, namely a focus not on the line. We have a fixed point, our focus, and we have a fixed line, our directrix. Now, if we consider the distance from the focus to some arbitrary point on the parabola and its distance from a fixed line, the directrix, we have d sub 1 and we have d sub 2. Two distances, and the key here is that d sub 1 is equal to d sub 2. Moreover, we should consider that the vertex is at h comma k. Now, given that, we can think about the focus and the directrix. So the distance from the focus to the vertex and the vertex to the directrix are equal. So this distance here and this distance here are equal. Now, this implies that the focus must be at h comma k plus some number we'll call p. So it's definitely going to have the same x-coordinate. It's definitely going to be some units above k. So we'll say that's p. Likewise, for the directrix, so we have y is equal to k minus p. So now we have the focus, we have the directrix, we have the vertex. And we know that d sub 1 is equal to d sub 2. We have all we need to derive our equation. So let's do it. Now, in general, remember that distance between 2 points, let's say d point 1 and point 2, is just equal to the square root of the change in x squared plus the change in y squared. And this equation itself we can derive from the Pythagorean theorem. So what is d sub 1? We're moving from the focus to some arbitrary point x comma y. So we can think of it this way. The distance is from x comma y to h comma k plus p. So d sub 1 is equal to the square root of x minus h, quantity squared, plus, let's put some brackets there. We want to be very careful with our minus signs. So plus y minus parentheses k plus p, close parentheses, close brackets, squared. So that's d sub 1. So we're moving from our focus to our arbitrary point on the parabola. Now we want d sub 2. We want to think about going from that point, x comma y, to our directrix. So in other words, we can think about going from x comma y to here. This point here is definitely still going to be x for the x coordinate, but then we're going to get, for the y coordinate, k minus p. If we think about our directrix, x comma k minus p. So d sub 2, will be equal to x minus x, that quantity squared, plus y minus, and let me do the brackets again, right there. So y minus, parentheses, k minus p, close parentheses, close brackets, squared. So we know that d sub 1 is equal to d sub 2. We have two square roots there. Let's just square both sides. So we'll square this side, we'll square this side. So now we have x minus h, quantity squared, plus y minus, parentheses, k plus p, close parentheses, close brackets, that squared, is equal to x minus x, that quantity squared, plus brackets, y minus, parentheses, k minus p, close parentheses, close brackets, squared. Great. Let's just work our way through this. First, notice that we have this x minus x, well, that clearly is just a 0. That goes away. So now we have x minus h, that quantity squared. And let's, so to speak, expand this out. So we have that squared. So we have y squared minus 2y times the quantity k plus p plus the quantity k plus p, quantity squared, is equal to, now let's expand that out on the right-hand side, y squared minus 2y, parentheses, k minus p, close parentheses, plus, parentheses, k minus p, close parentheses, squared. Now notice we have on the left-hand side this y squared, on the right-hand side this y squared, and so those go away. So presently we have x minus h, quantity squared. Now let's expand this out. So we have minus 2ky minus 2py. Let's expand that out. That k plus p squared. So plus k squared plus 2kp plus p squared. Now let's do the right-hand side. Let's expand that out. Let's distribute that out. So we have minus 2ky plus 2py. Let's square that. Expand that out. Plus y squared minus 2kp plus p squared. Great. Let's see if we can simplify this. Well, on the left-hand side, for example, we have, this minus 2ky. On the right-hand side, we have this minus 2ky. Those go away. We have, on the left-hand side, this k squared. On the right-hand side, this k squared. We can get rid of those. On the left-hand side, we have this p squared. On the right-hand side, we have this p squared. Those go away. So presently, we have the quantity x minus h, quantity squared, minus 2py plus 2kp is equal to 2py minus 2kp. Great. There's a lot of things we can gather up. Get this minus 2py and this plus 2py together. Let's get this 2kp and this minus 2kp together. So we can get x minus h, quantity squared, is equal to, so we'll add 2py to both sides. So we have 4py. We'll subtract 2kp from both sides. So we get minus 4kp. And then we could factor the 4p out. So our final answer we'll just say is therefore x minus h, quantity squared, is equal to 4p times the quantity y minus k. So this equation here will model our parabola. The vertex is at h comma k. We can also note that the focus will be at h comma k plus p. Moreover, the directrix will be at y is equal to k minus p. And we can read off that information from this equation. Because note that the absolute value of p is really the distance vertex is to the focus, for example. In any case, this is how we can derive the formula of a parabola based on this geometrical definition. I hope this video has been helpful to you, and good luck to you. Until next time, bye for now.